everyone. In this video, we will discuss about the Python implementation of a basic convolutional neural network in detail. Right, just look at the image now. Like you can see the convolution. So there is a bird image and you can see that. So this is the input over here and you can see the output over here. There are multiple classes like bird, sunset, dog, cat, right? So what is happening here? It is used convolution plus some kind of non-linearity. And then pooling is shown over here, maximum pooling. So this is basically convolution plus pooling layers. And then it is connected to fully connected layer. And then there is a classification. So here in the output, it will identify like which one has the maximum probability. Accordingly, it will show us the output. So according to this case, like eventually what we expect is like it should be a bird, right? So like the probability of the bird should be higher so that we can say that the model is predicting correctly, right? So what are the fundamental CNN structures? Like it is something similar to multilayer perceptron because they only feed signals forward but have different kinds of layers unique to CNNs, right? A convolution layer in the sense it processes data in a small receptive field, that is filter, and pooling layer downsample along 2 dimensions, usually width and height, and then dense, that is fully connected layer, which is similar to hidden layers of MLPs. Like, so here the input image is the car. So what do you expect the output to be? Like here you can see car, truck, airplane, ship, and horse. Ultimately, we expect the output to be car. So if you look into this, this is shaded a lot, right? So green, it is shaded with the green because this has the maximum probability. So how the model is being over here, just look into that. Convolution, ReLU, which is non-linearity, convolution, ReLU, and then pooling, convolution, ReLU, convolution, ReLU, then pooling, convolution, ReLU, convolution, ReLU, and then pooling, right? So then it is shown fully connected, right? So this is how the network generally looks like. So what I'm doing is I'm taking a data set, right? So let me import all the libraries like NumPy, Matplotlib, and I'm going to take the data set from sklearn. So from sklearn, import data sets. From sklearn.model_selection, import train_test_split. I write this code because I'm going to do training and testing split. Then I'm doing np utils import to categorical. I'm loading the data set now. So data sets load digits. So the data set is taken. In case if I want to display any one of the image, I'm displaying the first number in the data set. It is saying that the label is 0, right? So x_data is data.images, and the target I'm taking it into y_data. So if I look at the shape of this x_data, 1797,8,8. So basically it is in 8x8 format, and y data is 1797 only. And then I'm planning to reshape this data into 3D format, right? And this allows the image format of TensorFlow backend. So this xdata.reshape, and I'm reshaping the data, right? Then I want to do one-hot encoding of this y data. So that is why I have written this code. And then I want to do train test split. So I'm taking the test size as 0.3, which means 30% data I'm taking for testing and 70% data I'm taking for training. And this random state I can give anything. And now I'm looking into my training shape and the shape of the data. Training is 1257881. So the testing is 540,881, right? And let us look into Y train, that is 1257, 10, and this is 540, 10. So what I'm going to do now, I'm going to create a model with a sequential. So from keras.models, import sequential, from keras import optimizers, from keras.layers import dense, activation, flatten, convolution 2D and max pooling 2D. So I have written the code mod is equal to, so basically I'm instantiating the model now. So in general, 2D convolution layer is used for image processing, and the size of the filter, that is the kernel size parameter, defines the width and height of receptive field, and the number of filters is equal to the depth of the next layer, and strides is how far a filter makes change in its position for each move, and the image can be zero padded in order to prevent getting too small, right? So now I'm adding convolution, and this is the input shape, right? These are the input shapes, and I'm writing number of filters, kernel size, stride, I'm giving padding as value, right? Fine. So then I'm using activation layer, and it is identical to the activation layer in MLP, and in general ReLU is used, right? So I'm adding activation function ReLU now. Now the next step is the pooling. So generally maximum pooling is used because it reduces the number of parameters. So if you look into this, you can see 1156 out of these four, the maximum is 6. So 6, 2, 4, 7, 8, 8 is the maximum. So 8, 3, 2, 1, 2, 3 is the maximum. So 3, and 1, 0, 3, 4, 4 is the maximum. So 4. So it is maximum pool with 2 cross 2 filters and stride 2. And now we can do maximum pooling with the size 2, 2, right? So the next one, what we are discussing is about dense, fully connected layer. Convolution and pooling layers can be connected to dense layers. Sometimes dense layers can be omitted, right? So let us try to look into this. Like if you look into this, the first one, what you can see is about input object, right? You can see about input object, dense layer, activation layer, embedding layer, masking layer, and lambda layer. So now we are trying to look into dense, right? If you want to look into documentation, you can use this, and you can see like arguments and how to do this, right? Fine. So I have added dense, I have written 50, and activation is equal to ReLU, right? And this is basically dense layer with 50 neurons, right? So the first, before that, I have to flatten it to be connected to dense layers, right? We all know that, right? Before connecting it to the dense layers, it has to be flattened, and then flattened and connected to 50 neurons with activation function ReLU. And then it is connected to 10 neurons to classify the instances, because there could be 10 classes, right? So the activation is softmax, because basically we are trying to identify the numbers, right? So it's going to be from 0 to 9. So definitely the number of classes is going to be 10, right? Fine. So now if we want to use optimizers, I have used is Adam, right? So here learning rate, I'm using it as 0.001, and I'm compiling the loss using categorical cross entropy, and optimizer is Adam here, and metrics is accuracy, and I have written, and then I'm now fitting the model with the training data, and just I'm looking into the plot of it, right? I have given epochs as 100, batch size as 50, and validation split as 0.2, right? So if you look into this, you can see that for 100 it is showing, and here you can see that 0. So basically this blue line stands for training, and the another one stands for the validation. If you want to evaluate the testing data score, right? So you can see that as loss is 0.0845 and accuracy is 9759, right? So the test accuracy is 9759, which is pretty good, right? Because this is actually a very good score, right? Hope you all understood what is CNN, how to write codes for this basic CNN model. Let's meet in the next lecture.